students. As I mean, photoelectric effect or the experimental study, taking economic study. That means last class we discussed Hollar's or Linard's observation of Linard already photoelectric effect or full idea that Linard give a theoretical idea of the photoelectric effect. So now we discuss about the experimental study of photoelectric effect. That means experimental study, how it is, why photoelectric effect is used. Okay, so what happened in photoelectric effect? Okay, at first you see photoelectric effect of সাধাৰণতে কি হয় সেইটো পৰা আমি আজি study কৰিম. So this is the evacuated glass tube. This is we already লিখাইছো. This is evacuated glass tube having cathode and anode. So cathode is a metal which is used to eject the electron, and anode is used to collect the electron ejected by the cathode. Here one end is cathode, other end is anode. Cathode emit the electron and anode collect the electron emit by the cathode. So there is a window. This is quartz window. Generally it is also used a glass window. Here সাধাৰণতে glass window use কৰিব পাৰো if the light radiation is visible light. যদি আমি ইয়াত visible light use কৰো তেতিয়াহলে আমি ইয়াত এই যেটো যিখন window use কৰো সেইখন আমি glassৰ use কৰিব পাৰো. ঠিক আছে? That means visible light can be easily passed through transparent glass. Okay, but it can be passed, that means ultraviolet ray can be passed through this. That means this is this glass window. Okay, so to transmit the ultraviolet ray, here we consider a glass window, sorry, quartz window. Okay, to transmit ultraviolet radiation, here we consider a quartz window. Okay, so if you apply ultraviolet radiation, then this cathode end, this cathode are metal. But if you consider visible red light, then this cathode will be alkali metal. That means sodium, potassium, like this. If we use visible light, then the cathode are alkali metal. When we use ultraviolet, then the cathodes are the metal except alkali metal. Okay, so this glass tube is connected with a high tension battery and rheostat and a 2-plug key through a commutator. This is commutator. Commutator means it's a reversing switch. Okay, so this switch, how it is connected? Suppose if this whole arrangement is pushed upward, if the whole arrangement is pulled upward, then these and these connect these two arms. This point and this point, a point আমি যদি উপরে টানি দিও উঠাই দিও, a point or a point এইটো ইয়াত টাচ কৰিব, এইটো ইয়াত টাচ কৰিব. ওকে, দেন কি হৈ যাব, গোটেই এৰেঞ্জমেন্টটো এই এনডৰ লগত এইটো পজিটিভ লাগিব, ক্যাথডৰ লগত এনেকৈ লাগিব. যদি আমি এইটো তললৈ হেঁচা মাৰি দিও, ঠিক আছে, তললৈ হেঁচা মাৰি দিয়াৰ লগে লগে এইটো ইয়াত লাগিলে আৰু এইটো ইয়াত লাগিলে, তেতিয়া এনডৰ লগত নিগেটিভ আৰু ক্যাথডৰ লগত positive. Generally cathode negative like it. ঠিক আছে? So what happened? So when ultraviolet light rays is incident on this metallic plate, okay, this metallic plate, then this metallic plate absorbs this energy. Then due to absorption of energy, the electrons of these metallic plates are excited. Due to absorption of ultraviolet radiation, the electrons of these metallic plates are excited. Then these electrons are ejected from this metallic plate. That means they are excited. The electrons are excited. Excited they have a tendency. These electrons have a tendency to overcome from cathode to anode. The electron tendency ahead. The tendency to this electron can be moved from cathode to anode. Okay. So definite frequency, for a certain frequency of incident radiation, the electrons are ejected from cathode to anode. At a definite frequency पर है, cathode definite frequency ultraviolet light incident होने हैं, cathode अपना anode लेके होगा electron emit करेगा. So that frequency is known as threshold frequency. Okay. So beyond threshold frequency, more than threshold frequency, if the ultraviolet lights are incident on it, then the electrons are ejected from cathode to anode. Okay? So the electrons which are ejected from cathode to anode, so that electrons are known as photoelectron, and due to the movement of photoelectron, a current is flowing in this arrangement. So that current is known as photocurrent. So when the electrons are ejected from cathode to anode, then these electrons are collected by the anode. So this anode is also known as collector, and cathode can emit the electron. So cathode is known as emitter, and anode is known as collector. Okay? So how photoelectric effect experimentally, why photoelectric effect is used? That means uses of photoelectric effect. That means photoelectric effect is used to study about the effect of photocurrent due to intensity of light, study about the photocurrent due to potential, and study about the photocurrent due to change in frequency of incident radiation. That means how potential is changed due to frequency of incident radiation. Now we discuss like this. Okay, so at first we see. So here we see effect of intensity. So effect of intensity. If the intensity of the light radiation, having frequency more than threshold frequency is increased, then amount of photoelectron ejected from cathode to anode is increases. Okay? If the intensity of the light radiations having frequency more than threshold frequency is increased, that means intensity of the light radiation incident on the cathode plate is increased, then amount of photoelectron ejected from cathode to anode is increases. So if the number of photoelectron is increased, then current is increased. Therefore, how intensity is affected? Due to intensity effect on current, if the intensity is increased, if we draw a graph in between intensity and photocurrent, if the intensity is increased, then amount of photocurrent is increased. That means the photocurrent is directly proportional to the intensity of the incident radiation. That means it is gradually increases. That means the photocurrent is increased due to increasing intensity of the light radiation falling on the metallic plate having frequency more than threshold frequency. So this is the effect of intensity of light radiations on photocurrent. So next we discuss about the how photocurrent is changed due to change in potential. Okay? So now effect of potential on photocurrent. So how photocurrent is changed due to change in potential. Okay? So here we consider along x-axis we consider anode potential, and along y-axis we consider photocurrent. Okay? So this is cathode and this is anode. Okay? So suppose in between cathode and anode, there is a potential difference. I mean, okay? Suppose in between cathode and anode we supply power supply, cathode and anode. Suppose this is negative potential and this is positive potential. Okay? So in between cathode and anode there is a potential difference, suppose 10 volt. 10 volt in between cathode and anode. 10 volt potential difference is supplied. Suppose then this here we get, suppose anode potential is suppose -5 and cathode potential is suppose -5 and anode potential is suppose +5. Okay? So this is cathode potential and this is anode potential. So this in between the two electrodes, cathode and anode, there is a potential differences, we get 10 volt. Okay? So at first you see this is anode potential. Okay? This is anode potential. We start the graph from this point. This is 0 potential. Okay? This is 0 potential. suppose আমি cathode potential to -5 বুলি ধৰি লৈছো আমি example হিচাপে লৈছো দেই suppose the cathode potential is -5 volt and anode potential is suppose 0 cathode potential to আমি -5 বুলি ধৰিলো আৰু anode potential to suppose 0 volt to 0 বুলি আমি consider কৰো anode potential is 0 volt in that case cathode and anode there is a potential difference that is 5 volt তেতিয়া cathode আৰু anode মাজত এটা potential difference থাকিব কিমান সেইটো হৈছে 5 volt ঠিক আছে এতিয়া চোৱা সেই যেতিয়া আমি সেই 5 volt potential difference supply দিও 5 volt potential difference supply লত কি হৈছে this is -5 and this is 5 plus 5 potential difference 10 volt if cathode potential to ধৰিলো -5 আৰু anode potential আমি 0 বুলি কনসিডাৰ কৰিম ঠিক আছে যদি anode potential to 0 হয় then there is a potential difference in between cathode and anode তেতিয়া কিন্তু anode আৰু cathode মাজত এটা potential difference থাকে আৰু সেই potential difference টো কিমান 5 volt যেতিয়া 5 volt potential difference থাকিব then the photoelectrons are moving from cathode to anode these photoelectrons are moving from cathode to anode then we get a current তেতিয়া আমি এটা কি পাম current পাম that means for 0 anode potential we get a current like this suppose for a definite frequency and definite intensity for a fixed frequency and a fixed intensity of light radiation for 0 anode potential we get a photo current okay so after this if anode potential is increased if anode potential is gradually increases tar pasot jodi ami anode potential to komane bahai diu if anode potential is gradually increases suppose this is it will be 0 asile then it will become +1 +2 +3 +4 +5 like this if the anode potential is gradually increases then photo current is gradually increases okay so at a certain potential that means after a certain value of anode potential all the photoelectrons ejected by the cathodes reach the anode potential that means reach the anode okay all the photoelectrons emitted by the cathodes are reached to the anode surface okay so in that case the current becomes constant hey condition to in that case the current becomes constant so that current is known as saturation current this is saturation current this is saturation current okay next if you decrease ami eta process to ulta ke if you decrease the anode potential then what happens the anode potential is gradually decreases from +5 to -5 what happens anode potential is gradually decreases then +5 +4 +3 +2 +1 0 then photo current is gradually decreases so when anode potential is 0 then photo current is not 0 okay after that again by using commutator that means reversing switch the anode potential is sensed that means anode potential is sensed that means its electron is sensed then it becomes positive to negative okay so 0 next we get -1 -3 -4 -5 that means this anode potential is gradually decreases and photo current is also gradually decreases okay +5 opra komi kiman le panhe -5 when cathode potential and anode potential becomes equal then the potential difference in between that means for a certain value of anode potential the in between them potential difference is 0 then a current flowing through the circuit becomes for a definite value that is negative value of anode potential usually coming for a definite negative value of anode potential the photo current becomes 0 so that potential is known as anode potential this is 0 the negative value of anode potential for which the photo current becomes 0 is known as stopping potential. It is known as stopping potential. Okay? So if you consider another intensity, that means low intensity, then we get similar graph, but current is this. But here the stopping potential is remains same. In that case, if you change the intensity of the light radiation, then current is changed, but stopping potential is not changed. So from this graph, we conclude that the stopping potential is independent of intensity of light radiation. That means how potential is changed in photocurrent like this, but from this we get the stopping potential is independent of the intensity of the light radiation. Okay? So next we discuss how potential is affected by the frequency of the incident radiation. Okay? So this is the last observation. Okay? So here effect of frequency of incident radiation on stopping potential. Okay? So here in the cathode plate, suppose the frequency of the incident radiation changes by keeping constant intensity of the light radiation. Intensity to constant rakhibai. By keeping intensity of the light radiation, if the frequency of the incident radiation is changed, then how photocurrent is changed? And here to put study. Okay. So if the frequency of the incident radiation is changed by keeping at constant intensity of light, then this observation should take place. Okay. So this first observation is similar to the previous graph. That means effect of potential on photocurrent. Okay. So this first graph, suppose this is the definite frequency of incident radiation is nu1 for a certain intensity. We get a graph like this. So this is saturation current. Okay. Here intensity is constant. Okay. So for a definite intensity and definite frequency, we get this graph. This is first graph. This is the one graph. Okay. If the frequency is increased at the same intensity, then we get this graph. Saturation current is same. Saturation current is same. Intensity is same, but current will be different. Okay. Current will be different. Why? Why current will be different? Because frequency is changed. That means frequency is increased. So here we get frequency is increased. Then the stopping potential will be changed. Here the stopping potential is already negative, and it is more than previous one. Okay. So next in third case, frequency is again increased. Again frequency is increased. Then saturation current is remain same. For same intensity, saturation current is same, but stopping potential again changes. That means here frequency nu3 greater than nu2 greater than nu1. Nu3 greater than nu2 greater than nu1. Therefore, stopping potential V03, V02 greater than V01. That means V03 is maximum. So from this graph we get saturation current is independent of frequency of incident radiation. 1 point. Next point, stopping potential is changed due to change in frequency of the incident radiation. Stopping potential is changed due to change in frequency of incident radiation. Okay. So next we get how stopping potential is changed by changing frequency. Okay. So from next in another part we get stopping potential, how stopping potential and frequency is related. Okay. How stopping potential and frequency related. So that means it is directly proportional. If we consider a graph in between potential and frequency, then graph will be a straight line. Okay. So next we discuss of that part. Okay. So this is the main uses of photoelectric effect. First one is, what is the uses of photoelectric? First one is how photocurrent is sensed due to increasing intensity of light. Second one, how photocurrent is sensed due to change in stopping potential, that means due to change in potential. Next, effect of frequency of incident radiation on this is stopping potential. Okay, so stopping potential is always negative. So next we discuss about the laws of photoelectricity and photon picture of light. Okay, thank you.